Hello everyone, and welcome to this partner webinar, Building More Reliable Bluetooth LE Products with Memfault. We're excited today to have with us Heiko Behrens from Memfault. Heiko, could you tell us a little bit about yourself?
Sure. Hey, I'm Heiko Behrens, head of product here at Memfault. I've been in the software industry for more than 20 years now, spending a good chunk of the last decade at well-known hardware companies. And I believe that we can drastically improve how we develop and manage hardware products by learning from the software industry, how that software industry thinks about software products. And here at Memfault, I find great joy at helping closing that gap.
Thank you, Heiko. We also have Devin Jablonski. Devin, could you please introduce yourself?
Hey everyone, nice to meet you. I'm Devin. I run our partnerships program here, interfacing with Nordic and Nordic's customers. Very often my background is in the radar and signal processing world of embedded computing. And I've been here at Memfault for a year and a half now, and I'm really passionate about reliability. I used to work in, as I said, defense computing, where reliability was always really key. And that's what really drives my passion here at Memfault.
Thank you, Devin. And finally, myself, I'm Ali Aljani. I'm a developer marketing manager here at Nordic Semiconductor, and today I'll be your host. So let's jump into some webinar practicalities. The duration of the webinar is around 45 minutes, with 15 minutes at the end for Q&A. Questions are highly encouraged. Please type your question at the top of the right side bar in the Ask a Question to the Speaker box. We will answer your questions at the end of the webinar anonymously. The chat box at the bottom of the sidebar is not anonymous, and please do not use it for questions. If you have more questions after the webinar, go to devzone.nordicsemi.com for Nordic-related questions and memfault.com/contact for help with Memfault platform. Please note that a recording of the webinar will be available together with the presentation in the on-demand tab at webinars.nordicsemi.com. A little bit about our partnership with Memfault. So the constant demand for faster time to market has led to product design cycles getting shorter and shorter. This, of course, will increase the likelihood of bugs finding their way into deployed products. Partnering with Memfault has enabled Nordic customers to maintain and improve their devices more efficiently, with deep insight into deployed devices' performance. This partnership has already proven to deliver valuable insight into how Nordic Semiconductor customer deployed products behave in the field, and gives the ability to fix these issues proactively and quickly. Memfault integration into our unified SDK, the NRF Connect SDK, offers a complete reliability platform. Our customers will not only be able to monitor the fleet of deployed devices, but they will also be able to remotely debug the firmware of their devices through all sorts of configured metrics and capture the state of the firmware when a crash or a reset occurs. This gives developers the information needed to work on a firmware patch. And once the patch is developed, they can easily deploy it through Memfault over-the-air updates. So we have Memfault support for our cellular offering, the NRF 9160 system and package, since NRF Connect SDK version 1.6.0, which was released in June 2021. And now we have enhanced this partnership with a deep Memfault integration into our Bluetooth Low Energy offering, namely the NRF 52 and NRF 53 series, which will make it easier than ever for developers to accelerate time to market and deliver feature-rich products at scale. And with that, I'll hand the floor to Devin.
Thank you, Ali. Welcome, everyone. If this is your first time to Memfault, we'll go over today what exactly Memfault is, and hope you're excited to hear about that. If you were here last year for our discussion on the NRF 9160 integration, today will be a little bit different. We're going to focus on Bluetooth low energy based devices like your devices running on the NRF52 and NRF53 chipsets. As you see a teaser on the left-hand side, we have some really cool integration that came from the partnership with and working together with Nordic over the last year. As you saw, we're lucky to have here today our head of product, Heiko, who will go through a live demonstration and talk more about what's changed in the product over the last year, and then we'll do our Q&A. So at Memfault, our mission is to empower IoT device developers to build more reliable software, and reliability is really the key here. You may have noticed that some of the best IoT device companies out there are now hiring for device reliability engineers. This concept is much like site reliability engineering that you have heard about in the IT space, where IT professionals try to increase the uptime and meet service level agreements like 5 nines reliability and things of this nature. We're trying to bring this concept and tools like DevOps tools to embedded engineers. So device reliability engineering is really a set of principles and practices that incorporate those aspects of software development and applies them to the IoT and edge devices for development, maintenance, and improvement purposes. And the way we're doing that is with Memfault, which is the first IoT reliability platform. So as you see here, we're trying to create a feedback loop, much like most DevOps tools do in the IT space, but for embedded devices. And specifically how we're doing that is on the right-hand side, we're talking about a C-based SDK that is very lightweight and can go onto any IoT device and run in test and in production without impacting the behavior of the device, and bring 3 key features. The first is performance monitoring. Performance monitoring is meaning that the device can now self-report its behavior, performance metrics, and issues that are happening back to the engineers and the quality team and support team back in the office of the IoT vendor like yourself. In addition to just telling you what the device is experiencing, we want to eliminate the need to recreate the problem back in the lab such that you can see what's happening and fix the code. We are actually able to capture everything that's happening on the device at the time of an issue or the time of an event and display it to you in a web-based interface. And this is the feedback loop. That feedback loop is delivered in a fully managed cloud-based platform that gives a collaborative, shareable web interface that you can visualize everything that's going on from anywhere in the world. It doesn't require any cables to the device, and it can work over any connectivity. And today we're going to be talking a lot about the feedback loop and the connectivity path of Bluetooth. Once the engineers can see the problems going on and find the line of code without interrupting the customer's experience and without returning the device or doing a recreation step, they fix the code and they use Memfault right in the test environment or even pre-production in their test environment to be able to see the same types of visualizations and know that their code is going to work when they push it out into the field. Completing the iteration loop, our DeviceOps capabilities bring the ability to manage firmware, understand versions, and how the performance and the issues are behaving on a version-to-version basis. Memfault's compatible with all device management platforms like the other platforms available in Nordic's partner program, as well as providing its own ways to use Memfault to deliver OTA should you want to do so. So let's see a little bit how it works. These are some clips from our dashboard to give you an idea, and Heiko will go into a bit more detail. So we're talking about issue analysis at scale. Everything about Memfault is meant to be able to work with millions of devices and help distill information from many devices happening at once. So the first piece is detecting problems. In IoT devices today, usually the method is you wait for a customer to report an issue, and then you wait for 5 more customers to report issues until you really determine that there's something big going on that I need to dive into. Here we're looking at 60,000 devices on the day before, reporting issues all automatically, and we're seeing it instantly when it happened. So instantly, Memfault saves a bunch of time and potentially bad experience for your customer. Now, the next step for an engineer and a support team would usually be to try to talk to the customer and get more information from the device. Memfault very efficiently delivers information from the device and then analyzes it, detecting what type of problem happened, where in the code the problem happened, how many devices, and the time frame that it happened. With these several pieces of information, you're able to quickly understand what are the most important issues to look at, what is new, what is not new, and know what to work on. Sometimes there are more than one problem happening. Sometimes they're old problems that you didn't need to worry about anymore. You can answer that all here. And this is how Memfault helps find the bugs you care about, again, without relying on customers, without going and talking to customers, and without doing RMAs or service visits to the field. Now, as I mentioned, just knowing the problems is part of the battle and saves a ton of time being able to do that quickly. We want to give you all of the information you need to fix that problem. So as if you had a debugger hooked up to that device 2 days ago, as you see in the upper right-hand corner, we're able to capture this live in a production image without impacting device behavior, and be able to show in the Zephyr operating system as you use with your Nordic devices what threads were running, what line of code caused a crash, exception handler, everything in memory, registers, variables in your firmware, and logs from the time of the event. And you can even quickly jump between different devices of the thousands that might have had this problem and see how they differ, and quickly determine, again, with no interaction with your customer, what happened. We also have this concept of metrics, which not all problems manifest themselves in a single point in time with that capture of debug information. Sometimes you need information about what the device was experiencing in its environment or over time. So was your crash happening only when the device was at 50% battery life? Or was the CPU activity high at the time of the event, accelerometer running too often, something like this. And then very nice pieces that with just 2 lines of code, you can add new metrics. You don't have to talk to an IT team. You don't have to modify something in the cloud or a UI. Everything just populates itself through the system and shows up just from a line of code change in the firmware. And again, like our issue tracking and thinking about this at fleet scale, how do you understand all of the devices in aggregate? We have views to be able to see things like the average battery drop per hour of your entire fleet. And you can have these charts for any of your metrics or even issue types. And then you can compare across different versions of your software or hardware, or really any grouping you like, and be able to see, oh, did my update change the battery life for the better, for the worse? Was that expected? Or did I fix my issues between versions? We have a very powerful issue detection and alerting system. So we don't want you to have to be looking at a dashboard every day to see if there was a problem. We know you have a lot of things to do just managing your product and making sure it's successful in other ways. We're trying to help you with that. So Memfault can detect issues, it can detect thresholds of metrics and problems, and notify the specific engineers or support personnel that need to know about them. And that helps you get to a solution that much faster. As we're here talking today with Nordic, Nordic is a great partner of ours, and this is their diagram where they talk about how, as Aliyah mentioned in the intro, how they're trying to help you get to market faster and how they're trying to keep your product working better in the field. And as you see, I put the Memfault logo over a couple sections, and this is really where it helps you in your development process. From the minute you start testing your first code, you can start using Memfault to not require physical wires to the device, and also to share debugging and share metrics visualization across multiple engineers. In production and manufacturing, you can start using Memfault. So when you run manufacturing tests and the software spins up for the first time, you can capture device attributes like what manufacturing lot it was in and tag that to the devices. You can also capture, visualize and see if there were any issues that were unexpected in bring up or performance problems in those tests. And as mentioned, Memfault is really meant to span from testing into production, meaning that it is lightweight and it can run in your production firmware, so you deliver it out to the field and use it throughout the rest of the life cycle of your product. And it continues bringing this value and works at scale. So Memfault is included for free, and I'll explain a bit about that in a second, in the NRF Connect SDK 1.6 and above. In 1.6, as Ali mentioned, this was the support for the NRF 9160, and the more recent versions, 2.1 and above. We now support the Bluetooth low energy devices like the NRF 52 and NRF 53 series devices. We provide 100 free devices for you to use in those test environments and get started without any talking to a person or additional fees required. You're able to just go to our website, click in and create an account, and the documentation and our source code for the SDK are all available on public sources. So in terms of Bluetooth, I want to shift to what Heiko is going to be talking about today. And this idea of Memfault actually really started with Bluetooth devices. So we're designed with these in mind. And our founding team, and including Heiko, worked on the Pebble project, one of the first smartwatch devices, which for its time was really impressive with 7 days of battery life and really great capabilities and apps. And they were coming out with this new version that was a metal casing instead of their previous plastic casing. And what this meant was that they discovered that that was going to really impact the signal strength of the Bluetooth antenna, since this metal casing was almost like a Faraday cage around the internals of the device. And the question was, how is this going to impact our users? Is the watch going to disconnect too frequently from their phone? Are people going to complain about it? So what they did was they were able to take their firmware of their existing devices and instrument it with a bunch of metrics and the ability to capture these moments and look at them live as they happen. And also push this out to the existing devices, lowering the device's antenna strength or the radio signal strength to similar to what the new device would be. And because they had this observability into the metrics and behavior of the device, they were able to see actually this wasn't a big problem for the device. People don't usually move their watch that far from the phone that often and don't necessarily expect the connectivity to reach that far and what have you. So they were able to, with the confidence of being able to see the data, be able to verify, and then on their new device, be able to see those same metrics and be able to monitor in the field without waiting for customers to give a bad review. And that's really the key. And some of the challenges of Bluetooth devices are that they don't directly connect to the internet. They deal with phones. They deal with gateways if you're using a sensor out in the field and it talks to an IoT gateway, like our Nordic and Memfault partners of layered connectivity. That's a challenge often to get this kind of data off of the device. And that's what we're solving. Memfault is really built for Bluetooth device reliability. As mentioned, we are designed with this in mind. We are members and the only IoT reliability platform that are members of the Bluetooth SIG, working hard to try to improve the world of diagnostics for Bluetooth devices and make your lives easier building great products. And now with support out of the box with the Nordic NRF 52 and NRF 53 devices, some of the best Bluetooth chipsets on the market, we really are truly built for Bluetooth. And as you see across the bottom of the screen, there is a quote from one of our joint customers in Whoop who uses Memfault at scale in development and test and in the production. And they're able to really see that product performance and improve on it and iterate every day. And more of the best IoT companies are doing this. And the results they're seeing, just one type of metric is the number of resets per device. Reducing by up to 90%. And the key about this is being able to know that your devices are resetting. How many of you actually can know about a device resetting unless a customer reports it? as well as being able to find the problem and see that the results actually improve the device. So last thing, our customers today, just some logos that you may recognize. We work with any scale of device, whether you have millions of devices or your first prototype. If it's an electric scooter, a headphone, a wearable device, a sensor, an industrial factory process, medical devices, we have solutions for all of this, and we can talk about case studies with you as you may be interested. And with that, I'm going to hand over to Heiko to show how this works, and hopefully by the end of this presentation, you'll be able to set it up on your own product or on your Nordic dev kits.
Thank you, Devin, and hello to everyone out there once more. For anyone who joined late, I'm Heiko, Memfault's head of product. And now that Devin told you how Memfault helps you operating your devices, monitoring your fleet's performance, and enables you to debug devices in the field while they are far away from your desk, I want to shift gears and show how you can do that. And that's with your Nordic device, even if it's an NRF 53 or 52 that cannot directly talk to the internet. And I'm going to do that by telling a little journey how a crash propagates through the system and where the actual challenge is when you deal with a Bluetooth device. So let's assume top left corner, you have a bug somewhere in your software. Could be your own code, could be a library, sometimes even at a lower level. And in this particular case, we are dereferencing an old pointer, and ultimately that results in an unrecoverable situation. And then in your firmware, in case you're running Zephyr, your hard fault handler is being called. And what the Memfault SDK does is it adds itself into the hard fault handler and captures some state. And that really only happens if there is a hard fault. And what we do is we capture, the state of the registers, logs, and memory regions, predominantly the stack, and certain other regions that are freely configurable. All of this forms what we call a core dump that will later help anybody to reconstruct what was going on the device. And this core dump needs to be stored away because at the moment of the crash, you are about to reboot. So we need to store it away. Usually that is non-volatile memory or flash for later use. And then at some point, you're going to have connectivity. And depending on the data path, you can send larger or smaller data packages. Each transport has its own MTU size. And a year ago, when we gave a presentation about the NRF 9160, that's a great Nordic product with an LTE modem. Those devices could directly talk to the cloud, send all the data, and soon after a crash happened and the subsequent reboot, the data arrived. That's obviously not possible with a Bluetooth device. So the route our customers take is a sporadic Bluetooth connection to some gateway. Devin mentioned Pebble. What we did there is, because it's a consumer device, we did a tandem of the smartwatch and a phone. And for the most part, that was a permanent connection. But sometimes that was not, and sometimes the phone had no connection. So we treat this whole path as intermittent. Sometimes you don't have connectivity, but eventually all these little data packets arrive at the cloud through the help of a gateway. And then once in the cloud, at Memfault in our cloud platform, we reassemble all those data chunks back into the original core dump. And that's where the magic happens. We now do some data crunching on that. So think of that as looking at a core dump in GDB as if the device was connected at the moment of a crash. So we can reconstruct the backtrace, look at local variables, global variables, and so forth. But also we do further analysis so that we can structure crashes as they occur by software version or hardware type. And all of this is a numbers game. You may encounter a bug that only occurs every 10,000 hours of operation in the field. That's a bug that's usually impossible to reproduce in a lab or at the developer's desk. But if your fleet is large enough, you will have multiples of those each hour. And Memfault identifies those duplicates and marks them as such. You have a visibility that says it's actually 1,000 times that this crash happened, but only on 5 devices, or only across those software versions or other characteristics. And then once you have all of that, you get all those fancy charts and diagrams Devin was teasing you with earlier in the presentation. So that's really how we think about this flow. It's simplified. It's already 8 steps. And the good part is that for the most part, everything is being taken care of for you. Well, I mean, you still need to write the bugs. That's step 1. But step 2, 3, 4, and so forth, that's part of the Memfault SDK. And in particular, when combined with the NRF Connect SDK, that comes for free. It's literally a kconfig flag, and then also a project key, and that's it. Then there's connectivity. We talk about that later. And everything on the right-hand side, that's the cloud platform. It's a managed web application, as all the modern SaaS services look like. So I'm particularly concerned about the part in the middle. And how do you do that with a BLE device? Normally, or traditionally, customers had already some form of a data path, and then they piggyback on that. They say, okay, I can already send data through my gateway. It could be a phone, could be some stationary gateway or another device. And because it's a smart device, there is internet connectivity anyway, and there's just another data channel I dedicate to Memfault. But we recognize that oftentimes, initially, that gateway doesn't exist yet, and it's also difficult to implement. So to address this, Memfault and Nordic designed a GET service, which we call like the Memfault diagnostic service. And that is describing exactly that behavior. A device can send diagnostic information at arbitrary times in compatible packet sizes. And then there's the counterpart, which is a gateway implementation that is totally generic. Any gateway that implements the central that speaks to that peripheral forwards data to whatever installation of a diagnostic service. So that means if you are in possession of such a gateway and you're writing your next application that runs on a Nordic chip, it will simply forward the data, and you don't need to touch the gateway at all. And the best part is that Nordic even implements and provides with source code reference implementations of those gateways. So there is an Android version for this, there's an iOS version for this. And in general, around this GET profile, there's a Python implementation and even a web Bluetooth implementation. All of this is just part of the NRF Connect SDK 2.1. So what I want to do is I want to show that in action. I want to walk you through all of this as if you heard of Memfault for the first time, and with any luck, the demo gods will be friendly with me today, and we will see data at the end arriving at Memfault. So how do we go about this in the first place? And I would say the best part is to go to Memfault's documentation. You don't need to bookmark these URLs as part of the slide deck, which we circulate later. There is a page with plenty of links. But generally, there is an NRF Connect SDK integration guide that walks you through all the details, how to use it, how to set it up. It even predates the version 1.6, so how to deal with that. And ultimately, it also talks about that new Memfault diagnostic service down here, where we link to Nordic's documentation, which is fantastic. If you search for Memfault there, you have right now no results. That is uncommon. Okay, so it's searching. And there it is explained again how to integrate Memfault, but from Nordic's perspective. And they also go through the same details. One element they are describing here is how to set up an account. And they restate that as a Nordic customer, you have free access to Memfault services, which is great. And I'm clicking that and doing that right now. So I'm signing up for a new account. I'm Heiko Behrens. I'm with Memfault, and that is plus NRF webinar. That's the morning. We have a repetition of this webinar later today at memfault.com. And then a password, signing up, and that's it. And now I'm choosing a project name. I configure what this is running on. Here I'm running on an MCU, which is an NRF53. I'm going to demonstrate this on the 5340 dev kit. And that's obviously using GCC and CMake and GDB. Cool. And now I have a Memfault project, and the initial page I'm greeted with is in turn, again, the integration guide, where I have even snippets with a project key. These are literally the 2 lines I need to add to my project. So I could read all of this, or we fast forward because this is a webinar. And I'm actually creating a project right now off of a sample. And all the documentation here, as well as on the Nordic website, usually discusses how to do this on the command line. For demonstration purposes here, I'm using Nordic's NRF Connect Visual Studio extension, which is really convenient to use. What you can do there is you can create a new project, Bluetooth, and then from the samples that are part of the SDK. So you don't need to change the actual SDK source code. It really copies it into a new project here. And then I say webinar morning. And that is, again, a sample we link to. The sample is also open source. It's actually part of the SDK as well. That is just an application that does basic Bluetooth. So it advertises Bluetooth and responds to button presses, both to acknowledge the pairing ceremony and then also later to intentionally crash. So if you go to button handler, you see that at the bottom, this example actually performs a division by 0 to see what happens in case of a crash. I won't go through the actual guide here. Actually, yes, I will copy this line. It tells me that I need to update the project configuration. And here you can see that it's actually configured with Bluetooth. One of the services is the Memfault diagnostic service. And then there's also the Memfault project key. That is the one necessary thing you will read about in the guide. That is the link between the device sending data and which project to populate data to. And then each device needs to identify itself. There are different methods to do this. Usually people use the serial of a device. There are other methods that are more compliant with privacy concerns for some customers. In this example, and please don't repeat that, I'm hard coding the device identifier at build time. So this firmware will, no matter which device it runs on, always present itself as the same device. And that's it. Now I need to create a build configuration. I'm also doing this here from the plugin. I do have a 5340, that's it, and I'm building it now. And that's the one thing the plugin doesn't, or the Visual Studio Code extension doesn't make nicer. It's actually as slow as it always is when you build a project for the first time. So we will use this time to look at a Memfault project we set up before, just so that we orient ourselves in Memfault to see where these charts that Devin showed off actually come from. Memfault greets you with an overview page where you can see the fleet size. This is a demo project of only 100 devices, software distribution, but also which crashes happened, how often, and reboots, for example. So you can say yesterday, 3 devices or 3 times, 3 devices rebooted due to low power. You can look at this and then further slice and dice your fleet to look into such data. You can have custom charts to look at your particular scenario. Here we are measuring the counts of Bluetooth low energy disconnects as a particular heuristic for stability. And for example, you can now easily compare 2 different software versions, and clearly a newer software version is better with respect to disconnects. But the one really nice feature I want to allude to is looking at issues. So we looked at that core dump earlier and how it would be presented in Memfault. And this is, in this demo project, a core dump. You have, similar to any interactive debugger, such as GDB, a way to look at the backtrace, look at the local variables, globals, and so forth. To then deduce what kind of data this or like state the device was in the moment of the crash. You can also look at the device in particular and look at its data, how certain metrics evolved over time, correlate that with reboots to see if that was maybe triggered triggered by, I don't know, like a spinning CPU because of an infinite loop or similar scenarios. Cool. So, wow. Streaming the screen and building is not the fastest operation. I'm still building here. That will result in a fresh build of the firmware. Let me already switch over to the other camera I prepared. So if I go over to the deck, you see here on my desk, this is here on my desk, the NIF 5340 DK. And my plan is to flash that software with that little cable onto this board. So it's built. And now also really nice here is that first I need to turn it on. You may see the LEDs flashing. That you can enumerate all the devices, connect to the serial out. That would be here. And now I'm flashing what I've just built. Under the hood, this is just West Flash. It's actually the same commands you would normally run in the terminal. And then this happens. Flashing, flashing, flashing. At this point, nothing special has happened. All we did is we compiled with Memfault, provided a project key, gave it a serial number to identify itself against Memfault. And now the thing has flashed. And what I'm looking at is the actual interactive terminal with that device. So I can say device list, or there's also like a Memfault command, which can say get device info. And sure enough, you see that this is device 1. Cool. So earlier I showed you that the device can crash intentionally when you press button 4. Let's do that. I'm pressing button 4, and that is what you normally would see. You see just the registers, PCLR, and then also some of the registers, and that's it. The device reboots. And that's really only if it's connected to the device. Now, you could set a breakpoint and you could then debug at that location and try to get to the bottom of it, but only if that cable is attached to the device. Now, let's get one step further. What we have so far is effectively just the left-hand side of this, like steps 1 to 8. We have the Memfault SDK build into the image. We have a core dump created, hopefully, and then now we need to send over the data. Let me zoom out a little bit, and then what I'm having here is my phone on the right-hand side. And I'm launching the NRF Memfault app. You can get that in the App Store, both on iOS and Android. It's also really nice that the source code of that is open source, so you can look it up on GitHub. Let me quickly bring that up on my desktop here. So where is that? I thought, here it is. So that is just a Swift library you can pull into your application. And sure enough, if you look at the GitHub account from Nordic, you see that the corresponding Android library also exists. You can build this application yourself, but it's also pre-built and readily available on the App Store. So what I can do here is I can now launch that application and pair with the device on the left-hand side. Let me do this while we are looking at the logs. I'm clicking connect, and then what should happen is a pairing dialog. The logs say press 1 to confirm. I do that. I click pair here on the right-hand side, and that's it. This app from the App Store didn't know anything about our webinar or this application I ran here. This device is now paired, and you know what? I don't need any of these logs anymore anyway. So this is disconnected. I don't need any wires. And from here on, I have now a Bluetooth device connected to a gateway to send us data. If you go to our previously empty project, you now see that there is a device, and that's our device 1. It shows its software version and everything, and let's look at the issues. There's one catch. We cannot quite yet show you the backtraces and everything, because what Memfault does is a very efficient way of sending data from the device to Memfault. It only sends certain memory regions. So what we are going to need is we need the symbol files, not the source code, just the symbol files of your project in order to decipher the memory regions that we have just received. And that's the warning you see in the background here. We received a trace, but we cannot make sense of it until you give us this particular build. And then we use the GNU build ID to match it once we have received the corresponding ELF file. And usually people set this up with continuous integration so that everything happens automatically. Let me refresh here. But in our case, I just uploaded that once manually. Let's try that once more. Oh, here we go. I think it disappeared here. Yeah, thank God. The demo gods, I mean. So here's our hard fault. And if you look at this particular crash, you see the backtrace. There's a button handler. You have the local variables. And there was no wire attached, literally. This was all over the air. The local variable was buttons. It had the value 8 at the moment of crash. Let's quickly skim at the code. So here's the crash, division by 0. Here's the buttons. So let's see, with buttons and that value is different than 0. Let's go. What is this? Bit 4, 3. Bit is probably shifting left by a number of that value. And sure enough. So this is shifted left 3 times, so that is 8. So in fact, we had the local variable buttons was 8 when we divided by 0 here. And then from here, you can like drill deeper. For example, if you look at the globals, you can see, let's look at the global variables device serial. you can see that this is in fact the hard-coded serial. We can jump to that particular memory region and analyze it further. So this is really just a glimpse at how you can now use the data. And there's much more you can do once you have data at Memfault. But in short, what you have accomplished is with a zero implementation on the device, because the MDS service implementation is part of the SDK, and zero implementation for a gateway, because there is a different variations of gateways available. We send data from a Bluetooth-only device to the cloud. And that is really closing the gap for many of our Bluetooth customers. I want to really quickly go through a couple of product updates for everyone who attended our last webinar that we did with our partner Nordic, because we shipped quite some interesting improvements there. First and foremost, we never really talk here about OTA, but one critical thing we changed in our product is the ability to add incremental updates. So even smaller updates when you want to change the behavior of your fleet in the field. Memfault is capable to express very complex OTA scenarios, different paths, and is backed by a global content delivery network for scale. When you think about the DevOps cycle, there's collaboration involved, and you don't want to stare at charts all the time. You want to get alerted if there is an incident you need to react on, and the right person needs to respond. What we did this year is we doubled down on this idea and introduced the idea of we implemented a comprehensive system to model teams and their notification preferences, and alerts and issue events can be directed at specific groups of people, or Slack, or even external email and other systems. And that allows you to implement on-call procedures and manage specific alerts for subsystems, say connectivity issues being deferred to the antenna team. Devin briefly mentioned device attributes. They are really great to segment your fleet. You can basically say, are the battery issues I see related to a particular batch? Is it only the devices coming from this factory, maybe? Or you can see the version distribution in Europe versus North America. You can use it for inventory management, which devices are currently in repair, and so forth. Oftentimes, when you do a SoC project, it's in lockstep with other devices. A few years ago, I was helping with the development of virtual reality products. And there we had controllers and a headset that together formed the combined experience. And if something wasn't working, you needed to have the holistic view with two microcontrollers, the hand controllers and the headset together. And Memfault can now represent this by allowing you to express links between devices, and then you can very conveniently navigate and investigate between these connected devices. And then, of course, the Memfault diagnostic service we just described here. This is spec'd out. Anybody can implement it, and it's actually fairly straightforward. But the NIF Connect SDK has a reference implementation that, as you just saw, works even under stress. Cool. So if you look at the cycle Devin also used earlier, all these improvements I just described really, really quickly, I admit, fit nicely in that cycle. And they all together help improving you to think about reliability management of your fleet by replicating what the software industry is doing for a while now. You can start using all of this today. And in particular, you as Nordic users are in a very special position, because you can use this for free for, I think, 100 devices to really kick off the development. And then once your fleet scales in production, only then it becomes a paid product for you. This is the slide I was mentioning several times in the past. Deep links to all the different places. You can click on them after the webinar when we share the PDF with you. And I mentioned it a couple of times. While this webinar was about the nRF53 and Bluetooth Low Energy, I want to draw your attention to the last webinar we did with Nordic, where we showed the nRF 9160, which I think is a great fit for Memfault. That device comes with an LTE modem, which means it's going to be used in very remote environments. And that makes it virtually impossible to manage, diagnose, and debug it using traditional ways, which is like attaching a cable. I mean, the whole point of an LTE device is to be away from you, as a tracker, for example. You can find this webinar at memfault.com and also on Nordic's webinar channel. Cool, and that concludes our presentation today. And Devin and I are now happy to answer any questions you may have.